The broadcast is now starting. All attendees are in listen-only mode.
Good morning, or sorry, good afternoon. Wow, what a great start. Hi, my name is Anna Zylik. I am with ICF, and we are the vendor working on behalf of the sponsors of Energize Connecticut to bring these Passive House trainings to all of you. Thanks for joining us today. We will be recording this training and we will make this available afterwards for all of you. These trainings are at no cost, thanks to the sponsors of Energize Connecticut, and are a part of a partnership with Connecticut Passive House. A reminder that as part of this training and workforce development initiative, we are offering a 50% cost reimbursement for individuals pursuing either FIAS or FEE professional accreditation. This includes the cost of the trainings and the exam, and once you become certified, we'll work with you to process the 50% cost reimbursement. So don't hesitate to reach out to us if you have any questions on that. With that, I'll pass it over to Kian, who's also with ICF, to talk about the Passive House building incentives.
Yeah, thanks, Anna. And hi, everyone. Thanks for joining us for today's webinar. In addition to the no-cost educational webinar series that we're here for today and the professional accreditation reimbursements, the sponsors of Energize Connecticut also offer robust incentives for builders and developers who choose to pursue Passive House certification in multifamily projects with 5 units or more. The Passive House incentive design for Energize Connecticut is shown here on the slide and includes pre-construction incentives for things like feasibility studies and energy modeling, and post-construction incentives for full Passive House certification. Our goal is for everyone involved in multifamily construction in the state of Connecticut to be aware of these incentives. So if you're interested in learning more, please visit our website or contact us directly. The information there at the bottom of the slide. For questions during today's presentation, feel free to use the chat functionality. And Anna and I will relay those questions to Scott as we go through the presentation. And with that, I will turn it over to today's presenter, Scott. Scott, welcome.
Thanks, guys. Hi, everybody. My name is Scott Pusey. I'm with Stephen Winter Associates. This is a little bit about us and the offices and areas that we work out of and serve. Yeah, my name's Scott. I am a certified Passive House consultant. I'm also a Passive House verifier, an Energy Star rater, work a lot with these above code programs. And so I'm excited to talk to everybody today about air sealing. And this is the first of a 2-part workshop where we're going to talk about air sealing. And similar to the continuous insulation seminars and workshops that I did for the program here, we have some very similar learning objectives. To summarize, identify, describe, and recognize, but this time we're going to talk about air barriers. We're going to talk about typical materials and methods, challenging details, some common approaches that we see on projects that we work on and review, and then also, some of those alternative strategies that are out there. Very similar to the insulation workshops that we did. Hopefully you were able to catch some of those. We're going to talk about high performance basics. We're going to talk about these various types of air barrier products in sort of the middle segment. We'll do a 5-minute break around 2:50 and wrap up probably before 4. But yeah, hopefully stay within the time constraints that we've got today. So with that, we've got wanting to know a little bit from you all in the audience, if you wouldn't mind using the poll everywhere functionality. You can respond using text. You can go to the website there with that SWA 335 behind the backslash and let us know who you all are on the webinar today. Contractors, consultants, great. Love to have contractors out there. You guys are actually doing this, in the field. Architects, some design professionals, great. Any engineers in the house? All right, so architects, design folks seem to have the lead for this particular time. Great, thank you all for responding. We've got another one for you. Wondering if you would be able to tell us something that you're hoping to learn about today. You can link your responses together with an underscore so that it sort of comes through in a little more logical format, or you can just, you know, use a single word response. That's fine too. But wondering what you're looking to learn about today. Yep, thank you. Best practices, we will talk about that for sure. Anything else? Yep, cost effective. All right, so some insulation practices, techniques, great. We might not talk about too much about insulation strategies. Those were the first, that was the first series, but those, that has been recorded. You can go back and take a look at those workshops. Avoiding mold, cool. How to have existing buildings overcome barriers, sorry. Great, thanks for the responses, everybody. This is fantastic. Techniques. All right, I think we will be able to cover almost all of this with the exception of maybe some of those insulation strategies, but you can check out the website and take a look at those talks that we did earlier. For those of you that were on some of those earlier calls, the first couple slides are going to be review. We're talking about why we're doing this, having these presentations and trying to push these sort of more advanced and higher performing building techniques in order to try and get more buildings, more homes, you know, on the electrification pathway, using passive house as the pathway. And really, you know, any high performance sort of methodology will work, but we are going to talk pretty exclusively in terms of like what it would take to get to passive house. There are incentives that Keegan went over earlier, and the benefits that we've talked about before are listed here again. Resiliency, I know there was somebody in the second poll talking about trying to avoid mold, definitely falls under that that item there, along with healthy indoor air quality from ventilation systems, consistent temperatures. All of these things are benefits to building this way. Again, here's the workshop that we're on, air sealing and insulation for homes. We're going to talk a lot about air sealing today. So high performance basics. These are the goals of a high performance building, sort of the triple bottom line here: durability, building the energy reduction and cost reduction associated with a more efficient home. So how do we get there? We look at passive house as a pathway to high performance. It sort of puts guardrails around the design and construction of a building that is looking to be high performing, and it does it through super insulation, energy recovery, ventilation, minimize those thermal bridges with continuous insulation, and airtight construction. So we're going to talk a lot about airtight construction and airtightness today. This is what continuous insulation would look like, let's say in a basement, right? You've got quite a bit of underslab insulation, the seams are crossed over each other, lapped over each other, and it's all nice and neat and continuous. The airtightness, we are going to measure that with a blower door generally, and come up with what the leakage rate of the building is that you're working on. And then lastly, this balanced ventilation. So using heat energy, a heat recovery ventilator or energy recovery ventilator that's going to provide fresh filtered 24-hour a day air, man, having trouble getting all this out today. That heat exchanger is going to be at least 75% efficient. In most passive projects that we work on, that needs to be a little bit higher, more like the 85% efficient, and higher insulated and air sealed ductwork on that ventilation system, especially between the box and the outside intake and exhaust. So we've got a little placeholder in here for questions. Usually we haven't had any in the last ones, but Keegan, please do interrupt me if there are any questions early on.
Yes, Scott, there was one question. Are you primarily focusing today on new construction, retrofitting, or a little bit of both?
We're going to have a heavy focus on new construction. I can certainly sort of talk about retrofit strategies and techniques in terms of the different air barriers that we're going to take a look at to sort of like talk about their applicability. I can think of one that for sure would have good applicability, so I'll be sure to mention that when we get to it. But yeah, largely new builds, at least that's a lot of the photos and sort of details that we have that they're applicable to that new construction. So building enclosure. What is the building enclosure? This slide is talking about the 5, components of a building enclosure. So taking them one by one, the thermal insulation that is slowing the transfer of thermal energy in the form of heat, usually from inside to outside when it's cold out, but it also happens, obviously during the summer in the reverse direction. The air barrier is highlighted here. It's going to slow the movement of air through an assembly. That's what we're talking about today. But the other pieces of an enclosure are also going to be your water resistive barrier and the vapor retarder. The water resistive barrier, it sort of protects the assembly, the enclosure from bulk water, right? Like rain, snow, wind-driven rain, that sort of stuff. The vapor retarder slows the rate of vapor diffusion through the assembly. A lot of times we see that vapor retarder on the outside of a building, but also see it on the inside of a building. Just sort of depends where you're building. And then this drainage plane we wanted to mention here, not part of sort of like the classic enclosure attributes, but a drainage plane is important for that water resistive barrier to sort of like work as the manufacturer describes and intends it for it to work. It's basically a predictable path for shedding water, right? So any cladding that you put up on your above grade wall is usually held away from the water resistive barrier a little bit so that we can get that drainage plane and the water to shed off the structure. We've got a definition here for continuous air barrier. The combination of interconnected materials, assemblies, and sealed joints and components of the building envelope that minimize air leakage in or out of the building envelope. The very last sort of piece there is, the system. And so we're going to talk about sort of air barriers in terms of a system approach. That's how I think about them. That's sort of the training that I've received as a professional in the industry, is to think about the air barrier as a system and not so much about sort of like the individual parts. The individual parts are really, where the details and where some of those devils in the details can happen. But conceptually, when I think about an air barrier, I'm thinking about, the air barrier, right? Like singular. The air barrier is continuous, contiguous. It's going to keep the outside out and the inside in, is the best sort of like way to sum it up for me. The bullets here on this slide to say that 90% of moisture transport is by air movement, not diffusion through the materials, is sort of like a way to talk about why the importance of the air barrier, right? It's not just for energy efficiency and comfort, but all very much for durability. Don't want to have moisture-laden air moving through our building enclosures, especially when there is a cavity involved. Insulation is ineffective without air sealing. It's just not going to, especially fibrous insulation is kind of what we're talking about here. It's ineffective without that air seal. Needs to sort of work hand in hand. And a note to say that leakage occurs primarily at the edges, sort of, where these penetrations through the wall assembly happen and where the assembly transitions from one type to another. So some air barrier strategies. These are the different kind of air barriers that we're going to talk about in the main piece of our presentation today, which is to say we've got mechanically attached sheets, air barriers, we've got sheathing with integrated weather-resistant barriers, self-adhered sheet membranes, fluid applied. We've got closed cell spray foam with an asterisk. We'll talk about why in a little bit. Got some board stock. There's aero barrier, sort of a newer player on the block, the aero barrier system. It's pretty cool if you haven't seen it. We'll talk about that. And yeah, others like Pluroclima, SIGA, talk about those, and those are good ones for retrofit applications. So we are wondering, what is the most common air barrier type that you see on your projects? If you could just link any 2 or 3 word answers with an underscore, again, it'll make it easier to understand what you're trying to tell us. But what is it you guys using or seeing or designing zip? Are you using any of that Proclima or SIGA material? It's a little more of a European approach to air barriers. Spray foam, Tyvek, So taped plywood, that is a strategy for sure. Zip panels, awesome. Anything else, guys and gals? An interior membrane, cool. Foam, spray foam, fluid applied, great. So sort of a wide array of things that are being tried, used, designed, and I think we are going to be talking about all of these, which is fantastic. Fluid applied silicone. Huh. I guess they are they silicone based? I'm not sure. All right, let's get to the first one, mechanically attached sheet. So the biggest player in this space is Tyvek. At least, they sort of innovated this technique. It's been around for quite a while. It, is practiced by a lot of what we would call typical, quote unquote projects. It's held in place with staples or cap nails, and it could be used as an air barrier. And it's interesting with Tyvek, there are sort of like there's 2 sets of instructions to install Tyvek. One is to use Tyvek as just a water-resistant barrier, and then the other set of instructions is to use it also as an air barrier. And so the other bullet points here on the slide are to say that these things need to happen in order for Tyvek to work, conceivably work as an air barrier. So you gotta tape and seal all the seams. That's usually a given on whether it's water-resistant barrier or an air barrier. You're probably gonna do these on both of them, but the top and bottom edges need to be sealed to the structure, sealed to the framing, whatever it is on. The edges at the rough openings need to be sealed. The word here, sealed, is important. The siding contractors can't cut into it to get it to lie flat. Like, you can't make cuts, tears, rips, cuts. They all need to be fully patched in order for this material to be used as an air barrier. And that's largely applicable for all of the systems that we're going to use. Tears, rips, cuts, everything's, it's got to be patched, right? We're looking for a continuous air barrier. So that's the Tyvek. If you're interested in learning a little bit more, we've got Energy Vanguard is a good blog to check out, and Green Building Advisor also has a lot of good information about best practices on how to do this sort of like tried and true approach better, as well as it can be done. The next one is sheathing with an integrated air barrier. So examples of this products that are on the market include the Zip System by Huber and Armor Wall. I can't say for sure that I know who manufactures Armor Wall. Regardless, it's a continuous air barrier that's applied in the factory on the face of the board, right? It's sort of like impregnated into the sheathing material. And after that, the joints are sealed either on site with a tape. Pretty typical is what we see is a tape, or you can use a liquid flashing to sort of seal the seams. And then, of course, anything that's going through this board, this material is also going to get sealed. So your window penetrations, any mechanical penetrations, electrical, you know, yada, yada, yada. It goes on and on. So this is another type of material that, that you could use as an air barrier. And we're seeing it more and more on passive construction, on wood frame passive construction. Okay, so here is another option that we see, a self-adhered sheet membrane. So some of the advantages here is that it is a consistent thickness, and it sort of ensures that it's got the proper coverage, right? So this is also, you know, like a peel and stick. This would be that kind of category, that nomenclature. And because you are peeling and sticking it onto the building, that substrate needs to be free from debris and flat. And often it needs to be prepped with a primer. The primer is pretty key. When we've seen this type of approach fail, it's usually because the primer and the substrate is not properly applied and or prepped. This is following the manufacturer's directions to a T is very important for all of these kinds of air barriers, but especially it seems for these sheet membranes. You really need to look at the instructions and understand how the manufacturer is directing the project to install it. For the architects and designers on the call, I would encourage you, if you're looking at using a sheet membrane, to take a very hard look at the specs that you have going out with the project. That is going to require the contractor to follow all the manufacturer's directions, right? That's sometimes we've got a contractor that is pointing to the specs and saying, well, hey, look, nobody ever told me that we needed to use a primer. We thought that this self-adhered sheet membrane was the air barrier, and that's all we bid on. So we don't want to get into that situation. Many times this sheet membrane needs to be rolled flat to avoid wrinkles and fish mouths. If you don't know what a fish mouth is, we've got good examples and pictures of what that is, what those are coming up. But that's the sheet membrane. The next one is a fluid applied membrane. This is fairly typical approach on passive construction. It's a rolled or painted or sprayed onto the wall substrate. Many different kinds of substrates will accept this kind of fluid applied membrane, from plywood, Den's glass, even zip sheathing would be able to use this, if you wanted to, so kind of like belt and suspenders, but it can be easier to use around tricky geometry as opposed to a sheet good like we talked about earlier in the previous slide, right? This is going to be able to be painted on, sprayed on, whatever, and it's going to be applied over the entire wall area, not just around the seams, because there's lots of knots and things in plywood, and so in order to get to that passive level, we're looking to see that this fluid applied membrane would be applied. We usually see it to the entire surface area. It might be interesting to see how plywood would behave without it done over the entire field, but if I was your consultant on your project, we would be strongly encouraging that the fluid applied membrane be applied to the entire wall area. The next one we've got is this tried and true now at this point, I think we can say, closed cell spray foam. We've got the first bullet point here is saying that it can be controversial as an air barrier, because that's to say that there's a lot of things in terms of the installation that needs to happen, and also the detailing, in order to have spray foam, you know, really work as an air barrier. In the previous talks that we've done, the other workshops, we talked about spray foam with an asterisk as well, to say that in our experience, it works great as a thermal insulation, of, you know, going back to those layers of control on the enclosure. This is a great way to get a really high quality thermal barrier. When we're trying to get to sort of the very tight levels that Passive House is looking for, sometimes spray foam can be difficult to use just as that primary air barrier. We've found that usually an exterior air barrier is going to be needed to not only cover the, you know, the field of the wall, like it shows in the picture here, but also to cover those transitions from floor to ceiling and, or sorry, from floor to wall and wall to ceiling. Those transitions really need to be covered with some kind of like continuous air barrier. So we've got potential concerns about shrinkage. Again, some of the installation things need to be done just right. That's true for any product. We talked about it on the peel and stick membranes earlier, and you know, the same goes for spray foam too. There's things that need to be done right in the field so that it's installed correctly and performs as we all hope it does. Okay, another one. This one we're calling a board stock air barrier. So this is by DuPont, and the Thermax is the continuous exterior insulation that this product is sort of marketed under. And as far as I understand it, it's somewhat structural, right? This is shown as being applied to a steel structure, steel framing. I don't know the ins and the outs of the structural loading and the potential with this product, but I'm sure, you know, there's plenty of information on the manufacturer's website. We sort of just wanted to bring it up as another option to do an air barrier, because this one sort of clearly shows that just the joints have been sort of sealed together. So a little more in the vein of like a zip barrier, and less along the line of, you know, having to do a fluid applied membrane over all of this, right? This is foil faced continuous exterior insulation that is going to act as an air barrier as long as those joints are sealed. Aero barrier. So this is a mist applied air barrier. And so for those of you that are unfamiliar with this product, there's some good stuff online in terms of YouTube videos. I usually direct folks to a segment that This Old House did probably several years ago now at this point, sort of describing how the material works. They've got a little demonstration on an actual house that they built. I think it's in Massachusetts. So pretty cool product, but basically it can be applied at the drywall stage. It can be applied at the rough framing stage, you know, right before any cavity insulation would go in would be an option. Usually drywall though, because that's going to give you the barrier between the vented attic and the conditioned space below, right? You want to be able to seal that barrier with this product as well. So it's best for sealing smaller holes up to a ½ inch in size. So the way that it works is you pressurize the space with a blower door, basically. And then there's nozzles that are set up throughout the building, throughout the structure, and it's misted into the rooms. Because the building is under positive pressure, the airflow wants to, go from the inside to the outside of the structure, and it takes the mist, this fluid applied material, along with it. When it comes to an area where there's a hole in that air barrier, the mist and this water-based solution starts to sort of like pile up and eventually seals that hole. You've got to do a pretty good job on the air barrier to begin with in order for this to work. That 1/2-inch size is fairly large, but large gaps, large holes that are in the air barrier to begin with are not going to be sealed with this product. So it's a way to take a home that is maybe at that like 4 air changes per hour, all the way down to kind of as low as you want to go, more or less. You can get to passive house with this type of approach. More frequently, what we've seen in the projects that we've worked on, a kind of like a traditional air barrier on the exterior of the home is being used, sort of like, like neat code, 3 air changes per hour is what is in the IECC at the moment. And taking that 3 air changes per hour and getting you below that, getting you down to 1, and even more preferably around that passive house level of air tightness, which is in a slightly different metric. I think we're going to talk about that later, what the metrics are for air tightness.
Hey, Scott.
Yeah, go ahead.
Oh, yeah, I was just going to say there was a question just around retrofit applications, and if you had, other suggestions for retrofits as outside of just like blown in or strain insulation.
Yeah, this can be one of them. In a gut rehab, it will work. You've got to take care of the sort of the big holes like I was talking about. But this is a great option to use in an existing structure, especially some of those like smaller ones, the single family homes, the 1 to 4 unit buildings. But yeah, this can be an option. Even if you're not doing a full gut, you could consider using this. Like, there'd be some considerations you want to consider if you weren't doing a full gut and trying to use aero barrier. I think you would want to sort of talk through with the design team. But yeah, this can be an option. Spray foam, of course, can be an option if you're doing a gut rehab. I mean, if you're doing a gut rehab, like, you've got a lot of options for these interior applied ones, including the spray foam and the aero barrier, and this next one, which is an interior applied air barrier that is going to go between your rough framing and the drywall, more or less. So these options, the manufacturers here, Proclima and Siga, both offer this interior air barrier approach. And it's kind of like, it's not like that. It's not like this, but I'll say it anyway. In my mind, it's Tyvek for the inside. It's not the same material. And I'm sure Proclima and Siga can talk at length as to how their product is different from Tyvek. But you're basically using this material to, in a very detailed fashion, attach it to your framing, your studs, roof trusses, etc. on the inside, and then tape it to each other, tape around all of the penetrations in terms of windows and things that you can see here, and make a continuous air barrier. This is very typical in Europe. It's very typical with sort of like a masonry construction. We don't see it quite as much in the US for especially wood frame stuff. There's other options, but it can work, and it can work very well. You have sort of like access to this air barrier. You can test this air barrier before you hang drywall and cover the air barrier. So you have the ability to sort of detect any deficiencies and correct them. So yeah, another option that would work for kind of this, you know, the idea of a gut rehab. It's going to be very difficult to get the airtightness of a passive structure without doing gut in our experience. You know, you've really got to get down to, you know, where you're going to be making the stand from inside to outside in terms of air barrier. With that, it sort of like brings us to talking about the air barrier boundary, identifying it in plans, how to sort of detail it, and asking yourself, you know, for the construction, for the project that you're working on, you know, what is the conditioned boundary? What's the primary air barrier? Is it on the inside, the outside? Is it a combination of both? How does it interface with the other components? And does it pass the red line test? So the red line test is an air barrier continuity sort of exercise where you're going to be able to draw a continuous red line around the entire building perimeter, indicating the air sealed surface. Very typically, the air sealed surface is also going to be where your thermal resistive barrier is, but these two things are different. So to do this red line test well, you want to use both plan and section views, and you want to circle all of the transition points. This would include the corners, the changes of components, the cantilevers, you know, the assembly is changing direction, its shape, etc. The wall to roof connection and slab or floor to wall section also want to be, you know, looked at. How are you making that transition? What material are you using to go from, you know, maybe a zip system on the wall to a concrete foundation wall, right? Like, how are you going to make that transition? And then providing details for all of these and how it will be air sealed. This is a design exercise, right? So this is what sort of a typical air barrier continuity example looks like. What we really liked about this one is that it's color coded, right? This is from a real project. It's from a multifamily project, right? These are individual apartments. And so not only is it color coded, but it also comes with a guide and, you know, sort of like corresponding, what are these layers, right? In plan, it's very easy to see like, oh, here's the wall. But, you know, as we talked about earlier, like the enclosure, the wall is made up of these 4 layers. And so providing notes and being intentional about what each layer is doing and where it's located is very helpful. So the air barrier at exterior walls is the red here, right? So you can see it transitioning from wall to window as you go around. There's going to be penetrations in here. It's not necessarily noted here, but this is like, you know, the general approach, right? And then the purple is indicating in multifamily construction, we're often also compartmentalizing one apartment from the other, right? So this person's air is not being mixed with the corridor, and it's not being mixed with their neighbors. It's an airtight drywall approach is kind of like how you would probably approach doing compartmentalization in a multifamily building. But they're different, right? Like this air barrier is from inside to outside. It needs to be robust. All the details need to be included. Different materials are being used. The compartmentalization barrier is not quite as robust. It's probably just going to be done with drywall. There's still details that need to be worked out and done, but you know, it's not the same rigor. It's not the same materials that are being used, and so the architect, the design team here has sort of you know, shown that and indicated that. Got some other examples of what this is going to look like in terms of a section view, right? You can see the compartmentalization in purple from floor to floor. But the exterior air barrier, the one that we're really talking about today, is continuous along the entire face of the wall. You can see here where it transitions from the wall to the ceiling. And then, there's details that are called out. In this detail, we would expect to see what this material is going to look like as it transitions, especially from like maybe the parapet to the roof. This is more about compartmentalization. Also down here, there is an air barrier from the ground to the conditioned basement of this building. Generally, this, is kind of accomplished with a vapor barrier is kind of like, where you would be starting to see that sort of mix of a vapor and air barrier, right? And sort of the way that you define these different barriers is also pretty important. You want to be intentional with the language that you use. Sometimes a vapor barrier can also act as an air barrier, not always. You want to sort of like really call out those different control layers individually. That would be my recommendation, so that there's no confusion as to what each one of these things, what its purpose is and how it's meant to go from one assembly to the next. Okay, so compartmentalization, I talked about it a little bit, but it's just that. We're trying to keep this person's space sort of separate from the public space of the rest of the multifamily building, and then also the next guy's apartment as well. An airtight drywall approach is generally what we sort of look at. And we've actually got, I think we talk about it a little bit later. We've got some good details on our website. They're free and accessible to everybody on how to do this well in a multifamily building, this compartmentalization air barrier. And a lot of this testing for compartmentalization is a requirement for a program like Energy Star or Lead for Homes, which could have some incentive money available for following that. Okay, so backing up to sort of like the overall air barrier boundary, we used this image from Owens Corning to talk about insulation during our last workshop, but brought it back to sort of now talk about this in terms of an air barrier as well. We think it's a pretty good illustration of a home because it's got a lot of different conditions, right? Like, how are you going to transition from the foundation wall to the above grade wall? How are you going to transition from a crawl space to an above grade wall? There's some attic knee wall details over here. This is over in a garage, right? So the air barrier is going to want to follow everywhere that this insulation is, and the design team needs to be able to sort of like provide the directions for the contractor and the air sealing professional to be able to do it correctly the first time out of the gate. But this is to say, there can be some complexity when these air barriers change direction and material and all that sort of stuff. So when do you think that this strategy for planning the air barrier should happen? I think I sort of already answered this question, but wondering if you guys can weigh in on when should planning for the air barrier strategy on a project begin? Everybody's currently choosing A, which I would agree, as early as possible in schematic design or no later than DD in design development. If you're moving into like 50% construction documents and you've not even thought about an air barrier, boy, it's going to be tough. And if you're just going to figure it out on site as it comes out of the ground, good luck. You'll probably get to a code level of air tightness, but it's going to be very difficult and painful to get to a passive house level of tightness. I would go so far as even to say if you are going to use the air barrier system, you still have to have thought about a little bit about the air barrier that you're going to do. So,
hey Scott, before we move on, there's a couple questions I wanted to get to. Back to the 2 examples ago. Sorry, I forget the exact name. You described it as the Tyvek for interior. The question was that vapor permeable? Yeah, this one. Thanks.
yeah, usually they are. Usually they are vapor permeable. Usually, my understanding is never a vapor barrier. So maybe a vapor retarder. I'm not 100% sure on the different options offered by the 2 manufacturers, or even if there are any in terms of permeability. But my understanding is that they are vapor open, that any cavity behind these would have the ability to dry to the inside because that this material is vapor open. But I would need to double check that, and we would need to double check that in the product literature to be sure.
Got it. Okay. And then similarly, another vapor related question. If you have a foil-faced vapor closed exterior air barrier, are you worried that the assembly won't be able to dry out and would trap moisture?
So drying to the outside is sort of the question, right? Usually when we talk about this wall cavity, thinking about which way it's going to dry, from the inside or the outside or both. And in a lot of the literature that's out there, we talk about the ability to sort of dry to both, to the outside and to the inside. On the projects that we work on, we don't usually see a lot of polyisocyanurate or this foil-faced polyisocyanurate, which is kind of like, what this material is. We don't see it a ton. And the reason for that is trying to get it to do a little bit of drying to the outside. What you don't want to do is have sort of like no ability for a cavity to dry in either direction, right? So what is definitely not done would be this this foil-faced exterior vapor barrier that's applied to the outside of the cavity, and then also a vapor barrier on the inside, the other side of the wall cavity. Like we would not see that. That would be a huge red flag. But in a lot of the fluid applied stuff, these fluid applied membranes do have a perm rating that's going to allow it to sort of dry in both directions. And that was kind of one of the big contributions that Tyvek made, is the ability for that material to resist bulk water from penetrating the Tyvek. It's sort of a woven material, right? So the big droplets of water can't get through that, but the wovenness of the Tyvek does allow for vapor to move for the substrate to dry to the outside, right? And a lot of these sort of more advanced fluid applied membranes sometimes can also allow a little bit of drying as well through similar material properties. Closed cell spray foam does not allow any vapor transmission from inside to outside. It's put in the cavity usually, and so it's sort of like talking about the ability of an assembly to dry is sort of like NA. We really want that cavity to be able to dry from inside to outside. If there is no cavity, then the assumption is that you're going to be fine for vapor. Did that answer the question? So, any other, Keegan?
Yeah, there's one more. just asking about the air barrier properties or qualities of drywall, taped and mudded finished drywall.
Yep, good question. So taped and mudded finished drywall will act as a pretty good air barrier. It's going to act as a good air barrier in terms of like a code level, tightness, and where drywall sort of sometimes can fall down is the durability of it, and then also the ability to transition from one assembly to the next. So what I was sort of talking about at the beginning of the talk was thinking about the air barrier as a system and being able to transition from one assembly to the other, using appropriate materials to make those transitions. That's where drywall is not going to really perform for you, right? But in terms of an interior compartmentalization boundary, this purple line is being, it's all being achieved with drywall. The drywall is being taped and mudded to itself. So the ceiling to the wall connection, that's how we've been making that connection with drywall since it's come onto the market. And these transition points here are sort of like calling out at the floor to wall, for example. The drywall is going to run down, but we need a way to seal it to the subfloor. It's usually done to the bottom plate as well, right? Like making that connection right there is really important. If you don't make that connection, it's going to sort of open up the entire wall cavity to being able to pass air from one side of it to the other, right? It's a bypass. So that's a long-winded way to say that, yes, taped and mudded drywall can act as an air barrier. I think I left off here on the air barrier quality assurance. So QA, QC, we've all heard that sort of term before. I wanted to kind of break up what QA is and what QC is. So QA is a management tool, it's process oriented, it's a proactive strategy, it's sort of like, the prevention of defects, whereas QC is kind of like a corrective tool, right? It's can be very product oriented. It's a reactive strategy, right? It's sort of like looking, this is, what the inspection process is, QC, right? Looking for defects, maybe testing and verifying what is going on in the actual building. Whereas QA is different from that in that it's happening ahead of time, right? If you have a really good QA process, you will hopefully have less corrective action on the building that you're doing. So QA is plan review, perhaps plan and design review, and QC is field inspections, testing, and verification. How to get the air barrier stuff done correctly. This is some of the timelines that I alluded to earlier. So as early as schematic design, but sort of like, late in schematic design would be a good time to talk about the air barrier and how it's going to work. The design development, that 90% DD or 50% DD is really where a lot of the work is done and a lot of the details get hammered out. And then construction documents, that sort of phase of design, sort of finalizing any last minute things is generally where we see successful projects implementing the a good air barrier strategy. And obviously, this is for a larger scale project. But, on single family homes that have not been built before, custom homes, this same kind of process is probably going to be needed in order to get a really high performing airtight enclosure. So the quality assurance is focused on these tricky areas, the areas that are unsure of or unclear in details. So where you're not spending a lot of time is in the straight field of the wall, right? That's the easiest spot to use the air barrier material that you're using for the project. That's the easiest place to get that right. What we really need to dig into is the more challenging details and show them clearly. The devil here says he's here about the details. Just more about QA/QC. We really can't talk about this too much. This is kind of what I spend my professional life doing, the QA and QC of high performance projects. We talk about defining the quality with the owner. Usually if it's coming from the owner, the entire project team is very laser focused on that. I tell my project teams that if me being the certified passive house consultant, I cannot be the person that cares about the air barrier the most. Others on the project team need to care about that air barrier just as much as I do in order for it to be successful. If I'm the only one who cares, it's probably not going to end very well. It's not going to work out well, right? Because I'm not installing the air barrier. I'm just trying to ensure there's good details, good design, and everybody knows what they're supposed to be doing, and then follow up sort of in a kind of a sample of looking at the building to see that those areas were actually hit. And contractor training is essential for proper execution. The contractor training, it's not so much that we're showing when I do a contractor training for a project. It's not so much that I am showing the contractor how to tape a joint. It's more I am focusing the contractor's attention on some of the trickier details that the design architect planned, and sort of putting them on their radar to say you need to think about this particular transition because it's tricky. You might need some other materials. You need to if you have a way that you want to do it slightly differently, now's the time to sort of propose that instead of just trying it and seeing how it goes, right? That's the purpose of a contractor training, is to sort of have that dialogue and if necessary, explain what is included in the design that might be different from how they've done a project in the past. Here's everybody that is usually involved in an airtightness, the building enclosure. It's got a lot of trades. So foundation, waterproofing guys, roofing contractor, windows, storefront. The carpenters are especially really integral into getting this right, especially on wood frame buildings. Spray foam installer, and then the MEP trades. If you're going to put a hole through the air barrier, who is going to be correcting that? Is it the trade themselves, or is it a different contractor? So here's another opportunity to not have to listen to me talk quite as much, but what are some problems that you've seen during air barrier installation on your projects? What's the stuff that you guys are seeing where it's difficult to get a good air barrier installation accomplished, maybe in either design or in the field? Okay, so bad workmanship, penetrations, bad planning. I think is that it? All right, so I'm seeing a mix of both design issues, but then also installation issues, sort of like the workmanship. Oh, odd field conditions. That's a good one. Just getting the people who are actually doing the air barrier work to do it well, I think, is a large part of what you guys are saying. I've found that as well.
Yeah, so Scott, there's the question, and it kind of relates to this, is, you know, what do you suggest, or how can someone working on one of these projects streamline or make the process effective, so that, you know, you reference putting a hole in the barrier for one of the trades coming in afterwards? You know, how can you organize the project so that really you have like a minimal number of holes going into the air barrier, while still also, you know, streamlining the process of getting all the infrastructure that you need into the building in there?
Yeah, that's the tricky part. That's what makes this work fun and interesting. You know, it's not all technical. I will say it is a lot of mindset. There's no other way to put it. It's the mindset of not only the design team, but also the folks that are going to be, you know, bringing that design into the real world. They've got to be on board, and you know, I won't go so far as to say incentivized, but you know, usually once project teams find out that we're going to be doing testing at the end, you know, that's a score, right? Like you're going to get a score on how tight this building is. Sometimes that can really, you know, focus the mind and get some of this workmanship stuff, you know, somewhat ironed out. But like it's also a cooperative effort, depending on the size of the project. We see kind of like two approaches. Either one contractor is responsible for the air barrier, and they are responsible for kind of the QC part of that air barrier, right? So they're going around and double checking that holes that have been made have been sealed correctly, and sort of, you know, they are doing the sealing. The other approach is sort of more of a brigade, or, you know, by committee kind of approach, where, you know, the person, the trade that made the penetration is responsible for sealing it. The downside is that trade might not have the correct tools and product to be able to do the sealing. So when we've seen projects that just completely hit it out of the park in terms of their airtightness, they've done the former. They've had a specific, you know, usually the GC and you know, their assistant site superintendent usually is like, you know, the air barrier champion. They're having regular meetings with the installation guys. You know, it's being brought up on every weekly or bi-weekly project team meeting, but then also being enforced with regular kind of like inspections and stuff. You know, bringing that air barrier system to kind of the level of, like, you know, it's as important as what the trim carpentry is going to look like, right? Just because you can't see the air barrier once we cover it up doesn't mean that it's not important. And also, you know, being able to test that air barrier before you cover it up with something is also a great best practice. And so sequencing the project so that that can actually happen, you know, do that testing on the whole building before you put, you know, the siding on the outside. You need to, or the exterior insulation would be a better example. Doing that testing to see if the air barrier is actually performing as designed, as you want it to, would need to happen once, you know, all the windows are in, or the windows have been temporarily sealed with something, you know, the air barrier between maybe a vented attic and the space below is installed. Like, you know, there's sequencing stuff that has to be thought through. These are other factors impacting air barrier performance on the screen here. Missing materials, so if somebody's run out of material to make the connection that they really need to do, right? Like, you can't have that. The installers who don't know how to properly install the product. So, you know, you want to have the guys trained on the material that you're actually using. Talk about UV exposure beyond what the manufacturer calls for, right? Like, these air barriers are not generally meant to be out in the sun for months on end. They've got a shelf life in terms of UV exposure, and you've got to be aware of it. The fully adhered air barrier, the fully adhered peel and stick, not sticking to the walls, sometimes can go along with the UV exposure, but can also go along with it not being properly prepped. So let's look at like some examples of like good stuff, bad stuff, etc. Keegan, were there any other questions before we sort of move on to like looking at this in real life? All right.
Yeah, no, we can, there's a couple, but we can save them for a more generalized question break. Okay,
sounds good. So here's some good photos of what zip is going to look like. You can see here the tape is run, you know, straight across, right? Like parallel and perpendicular lines with tape. It looks neat. They've made the transition from the slab to the wall. It looks like it's been prepped. There's a couple of different materials on there. I think this is the water resistant barrier of the foundation wall and not the air barrier. The air barrier is this, it looks like this Henry blue screen material here. Moving on to the middle photo here, you can see that it looks like this zip tape has been put down ahead of this porch roof board being screwed to the structure, right? So you're not trying to do any origami around it. Like, you don't want to make this piece of framing part of your air barrier. It's not intended to be part of the air barrier. So don't make it that, right? Put the tape and connect the air barrier to itself and not to another piece of material, right? Same thing over here with this eave on the rake of the roof. This was attached sort of afterwards. We talked about some of the details, and we'll talk about them again later after the break. But this concept of monopoly framing, where, you know, you're adding these pieces onto the building after you have already addressed the air barrier. So what are some photos of zip that doesn't look well, doesn't look good? So I said I would talk to you about fish mouths. These are fish mouths, right? This is a fish mouth right here. This joint, this piece of tape is not fully adhered to the zip membrane. There is a joint right here from one board to the next. This fish mouth connects that joint from the air from the inside to the air of the outside, and you can see it's repeated everywhere, right? So not only has this piece of tape not been fully adhered to the zip membrane by use of the roller, it's also got all sorts of fish mouths and, you know, ways to like sort of connect the inside to the outside, which is not what we want. That's the opposite of what an air barrier is supposed to be. So get a good roller. This is the, you know, there's a couple different couple different varieties of zip roller, but you got to roll the tape. Rolling the tape is going to sort of emulsify the sealant that is on this tape. It's got to have, you know, enough pressure to be able to make that chemical connection, that bonding to it. Using your hand is not enough. You have to roll it. You've got to get pressure on there. Here's some other examples of really bad zip install, right? Like this middle one is just atrocious. The tape's damaged, it's incomplete, it's not fully adhered. This one over here on the left, I mean, this is more of a framing issue. That's why we sort of called out framing as being one of the important trades, right? Like this is pretty terrible. For one, like, obviously it's completely miscut, this piece. And then for number two, you've got, I guess that corner is overlapping. This piece has been held wild, which is good. It's kind of what you want to have happen there. Yeah, you want to be able to make that, so you're going to breach from this face of the wall to this face of the wall with a wide piece of tape, not the standard 3-inch stuff or 3.5-inch stuff. And then the last one over here, lots of holes. This has not been taped yet, but even if it's going to be taped, like, will the tape be able to go from these holes, span this? Like, is this piece of tape going to be wide enough? This is a nailing joint, right? Like there's not a seam here, but like these holes need to get addressed. They need to be covered with tape or the liquid flash or whatever in order to make this a complete air barrier. Here's more stuff that we see with zip. So a fish mouth going sort of the upward way is also a water intrusion issue, right? This electrical penetration has not been treated with anything, so probably liquid flash would be a great thing to use there. And then this is kind of more of a design issue, and this can happen not necessarily with just zip, with kind of any kind of air barrier, but like, the structural support of this porch roof is going right through the air barrier. Nobody is doing anybody any favors in having, how to air seal this, right? Like, probably liquid flash, but then you've got the joint between these two pieces of LVL to also contend with. Probably sealing it from the inside at that point would be good, but there might be a better way to do this detail so that this air barrier can remain complete, contiguous, and intact. If you have this happening once or twice on your single family home, it might not be that big of a deal. But if it's repeated on a multifamily home, I mean, on a multifamily structure, you're really asking for it. And I know we're going past our break here, but it is coming. We are going to have a break in a second. Here's some good photos of sheet membrane. In this particular Henry Blueskin product, the aqua stuff is the primer. So we can clearly see primer has been applied. These guys, in fact, are spraying it on, right? You can spray or roll that primer onto it. And it's been rolled. This looks really good. Contrast that with stuff that has not been fully adhered. It's not been rolled. It's not been primed. And this is what the product looks like when you don't follow the directions, the installation instructions. It's not a silver bullet. You've got to install it properly. And then here on this last one, it's just completely missing at the corner, right? Big hole there. It's got to be corrected. More sheet membrane stuff. This one, there is no primer on here. It's being held in place with staples, which is not what the manufacturer directs, and is not going to result in an air barrier. This is just another material hung on the building at this point. It's not an air barrier because these seams have not been treated, and it's not been rolled onto the substrate, and we can pretty much say it's not been treated with any primer. This one just has membrane, the tear in the membrane, that sort of stuff happens. That's where that QC process really comes into play. Yeah, so I'm going to say I just want to scoot ahead here and see. Oh yeah, so we're a little bit further down. Let's take our break now. We can do a question session, but we're sort of past that 3 o'clock stage when I wanted to do that break. Keegan, are there any other questions that we want to talk about before the break?
Yeah, just a couple quick questions before we break. Are the penetrations for nail and fastener penetrations in the zip system, are they self-sealing, or how are those addressed as part of the sealing process?
Yeah, it's my understanding that as long as you don't overdrive the fastener, it's going to be fine. And that's in the instructions from Huber. That's what we tell our project teams, as long as it's not, overdriven. So if it's pulling past and pushing past sort of that, the barrier, the green or the brown barrier that's part of the material, then you're going to want to hit it with something. But as long as those fasteners are being installed at the right sort of, pressure, not being overdriven, you do not need to individually hit those nails.
Another one, for hot roof applications, is there anything other than, is closed cell spray foam the best choice? Is there anything other than that? And can the asphalt felting that goes underneath the shingles be considered any sort of air barrier?
No, the felt definitely cannot be considered an air barrier. What could maybe be an air barrier would be like an ice and water guard. That's kind of a peel and stick kind of thing. You could potentially use that. That'd be a very expensive way to do it. I think that stuff is, and it kind of tears, but I'm getting off topic. In terms of hot roof stuff, yeah, spray foam is we see that quite a bit, but there's some vented sort of like, you can do like the sloped roof. You can insulate that sloped roof, and then also do kind of like a venting channel outside of that. I've seen that on a couple projects. And then you would be able to use, kind of like a fibrous insulation in that case. But yeah, kind of the easiest way to do it is with spray foam.
And lastly, again, back to retrofit applications for a moment. We talked about drywall, but one person asked how old horsehair plaster walls compare to drywall in terms of air barrier.
Yeah, they perform really well as long as they're not cracked. A lot of plaster has cracked or will crack or whatever. It loses the key to the lath behind it, and it'll crack out. But especially in plaster, newer plaster, I think that's still pretty prevalent in New England. Plaster walls, it works really very well because it's almost like it's got properties of a liquid, applied kind of material at that point, right? It's consistently applied across the substrate. So yeah, plaster is gonna perform as an air barrier. Mm-hmm.
All right, that's it for questions. So if we want to take our break now, and
yeah, let's do it. What do we have? We'll say it's 3:20. We'll come back at 3:25, and I'll pick up where we left off. All right, so we're back. I'm going to cover these last couple of bits about mostly compartmentalization. It's not the primary topic of today's talk, but it is pretty important in terms of any kind of multifamily construction. So it's this idea of an exterior air barrier versus a kind of like this compartmentalization barrier. So we spell it out here. Energy Star BIAS actually does require that you have a decent level of compartmentalization. It points to the Energy Star requirement. These are the benefits of compartmentalization. I talked about those earlier. It overlaps with fire stopping, but is not necessarily, you know, you can't use just fire stopping and end up with good compartmentalization. Townhouses, got to watch out for townhouses. So if you're doing townhouse construction, compartmentalization can be tricky, especially with shared firewalls, breakaway clips, that shaft wall liner kind of design can be very tricky. Here's the idea, right? Like we're just testing the air barrier of the unit itself, not the overall enclosure. Here's where we talk about, we do have this air sealing guide. So if you check out our website, or probably just do a Google search for Stephen Winter Associates air sealing guides. We've got them for multifamily masonry, multifamily steel, and wood. This is what you'll see when you look at them, sort of very much with an architect in mind in terms of how it's detailed. Each one of these things has a corresponding detail to go along with it. So this is at a demising wall between an interior wall and an exterior corridor wall, right? So this is an apartment on this side, apartment on that side. The corridor is to the top, to the plant north here. And we're talking about, you know, sealing the penetration, or sealing the, this is a wire here, sealing that, you know, from the wall to the cavity of the other wall, right? Also talking about using continuous piece of drywall, sort of holding the framing back so that a continuous piece of drywall can be run, slipped behind this demising wall, behind this party wall. So stuff like that. Key areas for compartmentalization, like we said, it can come along with fire sealing, not always. Here's some airtight drywall stuff. Seal kitchen penetrations coming through the drywall because the drywall is acting as your compartmentalization barrier. This is a MC cable and metal box that's been covered with mastic. All those little holes and things really add up. And then of course this box has been sealed to the drywall. And then door frames, that sort of thing, you've got to be mindful of. So let's talk more about design and this wood framed line test. In terms of some of the details, this is kind of, you know, this is very easy to do. Yeah, my red line for the air barrier is going to be, you know, complete contiguous. It's easy to go from one to another. But you know, when you start getting into the details of it, like how are you going to make this transition, right? Like we said that the air barrier is following this red line. Well, okay, what are you going to do? In this case, the vapor barrier of the slab was wrapped up to make the connection to the air barrier of the wall. So that's the rigid insulation, that's the rigid insulation. Below slab vapor barrier, flashing, blah, blah, blah. Leave extra under slab vapor barrier before pouring the concrete slab on grade to allow connection to the vertical weather resistant barrier, right? In addition to that, we're calling out a drywall gasket, sill gasket. So this is a piece of rubber, a rubber gasket, not a regular sill seal. That is not an air barrier. Sill seal is meant to act as a capillary break between the wood and the masonry below, so that water doesn't wick up into the wood. It's not a device to create an air seal. This device that's being called out is a a gasket fastened to the underside of the plate before setting. The basis of design is this by Conservation of Technologies. It's a pretty beefy gasket, right? And so that is also being used to help maintain the continuous air barrier of the wall through the slab on grade and through the foundation wall. Okay, that's where that's the line of the air barrier. This is what it looks like in real life. Framed walls, above grade walls, and so this is a zip system, as you can see. This tape is pretty wide. That's kind of a recommendation that we've got for all of our zip jobs, is to use the wider tape. I think it's 6 inches as opposed to like the 3.5 standard. It's going to give you a little more wiggle room in terms of being able to get a lot of coverage on either side of the seam at corners. And so, you know, there's been a detail done here to show the sealing of the seams, you know, in terms of the air barrier, and then this inside corner on the outside, you know, clearly showing what that inside corner is going to look like. And for this one, you know, how the vinyl is going to be, how that vinyl corner post is going to sit in there. So it's great. What challenges have you guys seen with zip? If you don't use zip, I'd be curious to know that too. But has anybody on the call, on the webinar, had challenges either installing the taping or the liquid flash? Anybody have any issues with it? All right, sounds like you guys are professional installers or not using it.
It's out there. Well, there's one question while we wait to see if any answers come through there. You mentioned air barrier, under slab air barrier. Do you want to just elaborate on that? You know, is the concrete foundation not an air barrier? What type of you know, methodologies is there?
Yeah. So I sort of alluded to it. Oh, and here's some. So the intersections shingling. Oh, Tyvek overlapping. So OSB's vulnerability to moisture. Okay, so trying to seal probably plywood with a tape. Getting carpenters to roll the tape. Amen, brother. Not working in NC or exist. Yeah, not okay. All right, so I'll address and talk about this for the underslab. So yes, this concrete is generally going to work as a pretty good air barrier, but to have it be continuous under here, right? Like, it's not about the field of the concrete per se. There's also going to be penetrations that are coming up through the concrete, and so having an air barrier underneath it, it can also act as the vapor barrier. That's, you know, very common in this particular application under the slab. But it's more about the transition from the slab to the concrete wall, right? So if for some reason, I don't know, you didn't have a sheet applied, this brand is called Stego. It's a very robust, I don't know what the mil rating is, but it's a really very durable piece of plastic meant to be underneath the slab. Like, if that was not here, then, you know, you're really relying very heavily on, you know, your your gasket connection. So it's nice to have kind of like a full piece of material that spans from one air barrier of the above grade wall to the other air barrier, kind of the concrete in this case. So it's kind of a roundabout answer to say that it's more about the transition, and kind of less like this can sometimes be the least of our worries in terms of air infiltration as far as air coming through the slab. Like that's not generally going to happen, but there are penetrations in the slab with pipes and venting and radon and all that sort of stuff that you want to be able to make that air seal underneath the concrete, not necessarily have to make the air seal from the concrete to those pipe penetrations that are then coming through the concrete. That's kind of a two-step process. If you have your air barrier under here, you can do the install, get all of it taped to all of the penetrations that are coming up from the slab, and you're kind of, you're done. You've made that continuous air barrier. So thanks everybody for answering. Looks like we've got a pretty complete list here. Getting carpets to roll the shape, stick the membranes. Tyvek is mentioned in there. I wonder if it's kind of like a two-part process where sometimes you're using zip and sometimes you're using Tyvek. I could see that would be an issue. Intersections, tape overlapping. Yes, we see all of this too. I think it was in a lot of the pictures that we've showed. All right, and I think we're going to be able to be on time here. We're on slide 67. We've got about 85 or so. So I might need to cruise through these a little bit, but this window to the main air barrier, windows coming through the above grade wall are a big area where air leakage could happen. What we generally see is a backer rod and caulk approach to getting these windows installed correctly. A lot of times in a passive construction, these windows are not flanged. They are clip applied, right? So they sort of use a clip to be held into the rough opening of the wall. And so what we have found is that a traditional kind of like spray foam of the cavity here is not going to be enough to meet those passive house requirements. What you want to use is a backer rod and caulk. Here you can see those clips that I was talking about. The caulk really does a nice job of getting all the way around it. You want to do that on the inside and the outside. 2 layers of caulk. Usually this is kind of the air barrier layer, and the outside one is really for water, but both of them, you want both of them to be, excuse me, airtight. This apparatus here is a way that we test. We do this test on every passive building that we work on. You can see that this window chamber, which is basically plastic sheeting, has been taped to the rough opening of the wall. And so we're not only testing if there's any air leakage in the window itself, but also this very important connection between the rough opening and the window. And I've got other pictures of that from the outside later. Wood frame band joists, using spray foam for the thermal layer is great, but as you can see, the air barrier on this construction is on the outside, where, in my opinion, it belongs. And so how this spray foam sort of like connects and touches itself and each other for air is not really all that important. It's really just there for thermal protection. More wood frame stuff with zip, ERV vents, ducting penetrations through a cavity. These are a little blurry, but you can see that, it's been done well. There's good adhesion of this metal duct coming through the air barrier. And here, this is the stretchy version of the zip tape. I can't quite remember what the technical term of that is, or what they call it, but that works really well on these types of penetrations. This tape can be put on sort of the outside of this and then stretched, as opposed to the regular tape that doesn't have that stretching ability. So around penetrations is where it really works well. You saw a picture of this earlier, which is the porches and balconies. So here showing that these seams have been taped before the ledger board has been put on. Attic hatches. Okay, so attic hatches for air sealing. Not only do you need a lot of insulation on an attic hatch in a passive construction, but you also need to construct something that's going to be pretty airtight. So this is the air barrier, the blue dotted line, and so it's showing how the connection between this framed sort of opening of the actual attic access, attic scuttle, has been connected to the air barrier of the ceiling. And then you can see the continuous air sealing gasket is also then between the actual hatch and you know, the air barrier created by the framing and the air barrier around it. So here's a framed roof to an above grade roof, or sorry, a framed wall to above grade, wait a minute, wood framed above grade to roof. Okay, so an above grade wall to the roof. You can see here that the air barrier is following the rake of the roof, and that there's going to be rigid insulation piled on top of that. Looking at this in the field, this is what it looked like. You can see that the zip tape was applied before the roof was built up on top of it. So having that detail right there to show and to remind everybody that we want to make this connection, that this is the air barrier of the building and this is the air barrier of the wall, to make that connection before you build up the rest of the roof assembly was critical. Here's a flat roof. Same thing, a little easier in a flat roof application. So the zip system of the actual roof, of the flat roof, has been taped to the wall, and the actual buildup of the insulation and all of the roof afterwards is done afterwards. Here's a really tricky one. This was a mansard roof design, and so it's got windows in it, of course. You can see all of this taping and everything. Getting all of this to work was very difficult on this project. The concept of the air barrier, though, sort of follows the slope of the roof. And so, you know, being intentional with where the air barrier is was really important to get this all to work in the construction phase. So the air barrier goes right up the mansard and attaches to the roof. This is parapet up here. And so the connection was made further back. Here is that parapet. Not the mansard design, but again, you can see it goes up and over and attaches to the membrane of, to the zip system underneath it, not to the membrane of the roof itself. This is a great way to do it. It really worked well on this particular project. The air test came out great. Some more examples of this roof to wall sequencing. Yeah, this image credit to Rissinger Build, concept of monopoly framing, where you complete the air barrier and then build up the roof, and having the structure and everything to be able to actually make that happen is where it comes into play in design. So we've got a question about this. This question is to you guys, to you all in the webinar, what you think is going to be, who should take responsibility for it. I sort of weighed in on what my thoughts are. Everyone, good one. It's not an either or question for this particular respondent, so good answer. Anybody else got an answer? That might be kind of the mic drop answer for that one. Yeah, site supervisor, sure. Main contractor, yep. All right, oh, cool. So it seems like there's consensus, a little bit of consensus that it should be the GC, the superintendent, you know, not necessarily a subcontractor. I would agree. I said that I would have another image of what this window install looks like. And so after having done this window test for air leakage, we found that just that small little bit of missing caulking on the outside, right? Now there were a couple more areas of this as you went around the outside of the rough opening, but that kind of area was causing this particular window to fail, to be beyond the leakage limit allowed for this square footage of enclosure in the FIAS requirement. So I measured what is the size of the window buck that I've sort of made here. I then calculated the square footage. From then, I see how much air leakage is going to happen in this square footage. You do the math and you see if it is above or below the leakage requirement. So if it's above, you go around and look for areas that it's deficient. We do this with theatrical fog, pump some fog into this chamber, put the pressure on it, and then you see it spilling out on the outside. This is a weep hole of the window, and when the window is installed and adjusted properly in the opening, you don't get any leakage through the weep holes. It's really, you know, it's just for water. Getting this install and sequencing, I alluded to this a little bit earlier, but the sequencing really important. You can't cover up the air barrier until the air barrier is, you know, done well, correctly, and ideally tested. In this situation, the masons were actually putting up this insulation. They were moving, you know, right on up the wall, but we hadn't had a chance to, you know, sign off on the air barrier. We weren't able to really remediate all of the areas on this building, and we actually missed the air tightness target by a couple hundred CFM on a 60 apartment multifamily building. It's a bummer. Foam relying, we talked about this during our last sessions, but using foam to rely and use it as an air barrier can be very tricky because it looks like it's all installed well, and you go to test it or look at it with an infrared camera, and you can see that, you know, even after sort of like doing some remediation with spray foam, it is still leaking. This gap right here, you know, once you look at it closely, you're like, oh yeah, of course it's going to leak there, but you didn't see that on your initial inspection because it looked so good from before. So I think that's about it. I'm wondering what your final thoughts and takeaways are on today's talk. If we've got any other final questions, now's a good time to type them in. Keegan, has anything else come in? Keegan, are you on mute? All right, so any other final thoughts or takeaways, please put into the poll everywhere thing. And if there aren't any other questions, that's really all we have for today. We've got another, the second half of this workshop to talk about a couple more details, give a little more information about, how we test and verify these things, the air barrier, that is. When you do whole building testing, it is a little different than just the compartmentalization testing. So we'll talk about that a little bit. But yeah, if there's, oh, cool. So wanting to see more products, I think, is some of the feedback there. That's good feedback. So yeah, the air barrier, the products that make up your air barrier can be very important, but thinking about the main gist of the presentation today was trying to think about how those different products connect to the other products, how those transitions are made. That's really where the devil in the details are.
Now, Scott, it doesn't look like there's any outstanding questions to answer.
Okay. Well, great. Thanks for joining us, everybody, and I hope you sign up for the next one. We've got more to talk about on this topic, and we'll look forward to seeing you then.
Yeah, so part 2 is a week from today, Tuesday, August 30th, again at 2 p.m. to 4 p.m. That'll again be brought to you by the sponsors of Energize Connecticut. And Anna, did you have closing remarks for where folks can find the recording today and also for CEUs?
Yes. Yep. So if anyone wishes to receive AIA or BPI credits, we will be sending out a survey in an email to collect your information. That will be sent out after our part 2 session that's happening next week. So look out for that in your inbox if you wish to receive the CEU credits. And also we will be providing a link to where the recording and slide deck will be posted online.
Yeah, thanks, Anna. And just a quick programming note: if you are aiming for the CEUs for either AIA or BPI, you will need to attend both part 1 and part 2 of the workshop. So in that case, we'll plan to see you next week. But other than that, yeah, thanks, Scott.
Yeah, thank you guys. Thanks for joining. We'll talk soon.
Yep.
Yeah, thanks to everyone who joined. Take care.
Bye-bye.